What's up, interweb? Okay, today this is what we did on Monday, the 20th, September 20th. If we have, first of all, let's talk about some vocabulary. Okay, the 2 is called the index. The 3 is the radicand. You're not going to see that a whole lot, but you will see it some. And this thing is called the radical. If there's not a number up here, it's assumed to be a 2. In other words, the square root of. So if we had this, the square root of 9 is plus or minus 3. Because remember, what does the radical mean? What number times itself? What number times itself is 9? Well, 3 times 3 is 9, but also negative 3 times negative 3 is also 9. And Wednesday we'll talk about this some. If you have the square root of negative 16, up until now, or up until Wednesday anyway, this was undefined. Because nothing times itself is going to be a negative number. We have a way of dealing with that, and we'll get into it Wednesday. Now, if we have square root of 3 times the square root of 5, now we have to have the same index. To be able to join these two things. So this is equal to the square root of 3 times 5, which is the square root of 15. But again, the only time you can do this is when the indexes or indices are the same. So if you have the square root of 3 times the cube root of, in other words, what number times itself 3 times is 5, there's nothing you can do here. So the answer to this is the square root of 3 times the square cube root of 5. There's nothing you can do. Have to have the same index. Now, if you have this, if you have the square root of 7a times the square root of 10b, can we multiply these two things? Yes, because the indices are the same. So this is the square root of 70 AB. A times B is AB, so we can do that. Okay. Okay. Now the quotient rule, you remember, is the answer you get when you divide. Q-U-O-T-I-E. Quotient rule. So if you have the square root of A divided by the square root of B, you can put this under the same radical, A over B, just like that. Take a drink. Now, what if we have this? Square root of 9 over 16. This is the same thing as if we went backwards from here. We could have the square root of 9 over the square root of 16. And the square root of 9 is 3. This is a 6. Over the square root of 4. Actually, it's going to be plus or minus. But anyway. Okay, everybody got that? Okay. simplifying roots. F-Y-I-N-G. Simplifying roots. If you have the square root of 8, can we take the square root of 8 without a calculator? No. So what we want to do is we want to factor this 8 where one of the factors is a perfect square. Now the perfect squares are, let's see, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, and so on. These are perfect squares. I think I sent you a sheet on these with all the squares and the cubes. So what can we factor 8 into where one of them is one of these numbers? Square root of 4 times the square root of 2 is the square root of 8. Now the square root of 4 is 2 times, and we don't know, we don't care what that is. Okay? Once you take the square root of it, it comes out of the radical. And what if we have the square root of 32? Now, what are the factors of 32 where one of them is a perfect square? It's the square root of 16 times 2. Now you can put them under the same radical if you want. Make it a little easier. The square root of 16 is 4. Square root of 2 is the square root of 2. Nothing else we can do. They really don't get any more difficult than that. The numbers just get larger is the only thing. For instance, if we have the square root of, my big fat hand in the way, the square root of 75 is the square root of 25 times 3. Is that right? Yeah. And the square root of 25 is 5, so it comes out of the radical once you take the square root of it. Times the square root of 3, we don't know and we don't care. How about the square root of 500? That is the square root of 100, which we know is 10, times 5. So it's 10 times the square root of 5. Okay? And the square root of x squared, any number squared. Remember, x squared is x times x. So what number times itself is x squared? It's just nothing more than x. And if we have this, the square root of b to the 4th power, what number times itself is b to the 4th? Now remember, the index here is 2, so we just divide the 4 by 2 and we get b squared. Now let's do it backwards to make sure. B squared times b squared is b to the 4th, so we're probably right. And what if we have this? What if we have square root of c to the 5th power? Now what we're going to have to do is factor the c to the 5th into square root of c to the 4th, which we can deal with, times c. C to the 4th times c is c to the 5th. Now what's the square root of c to the 4th? C squared times the square root of c. And if we have the square root of d to the 7th, remember we want an even number here when our index is 2. So we want square root of d times d to the 6th. Square root of d, we don't know and we don't care. Leave it under the radical. And the square root of d to the 6th is d cubed. All we do is we divide the exponent by 2 or 3 or whatever. So what if we have this? What if we have the cube root of e to the 6th? Now again, all we're going to do is we're going to divide the 6 by 3, and we get e squared. Remember now, if we do it backwards, what we want is e squared times itself 3 times e squared is e to the 6th. So we're correct. Okay, Pythagorean theorem. You're going to see one of these on the final exam. You might see 2 of them, but I doubt it. Whenever you see a right triangle looks like this, kind of. Pretend this is a right triangle. First thing you think about when you see a right triangle is that old dead Greek guy, Pythagoras. A, B, and C. Okay, A and B are the 2 legs, the ones on either side of the right angle. But C has to be this one, the hypotenuse. Now the Pythagorean theorem states a squared plus b squared equals c squared. Okay, so if A is 3, B is 4, let's call them feet, and we don't know what C is. A squared is 3 squared plus, and B is 4 squared equals C squared is, we don't know, x squared. Now it's just order of operation. We do exponents first. So that's 9 plus 16 equals x squared. So 25 equals x squared. Take the square root of it so we can get that, so we can find out what x is. So x is 5. Is it plus or minus 5? No, because this is distance. Distance is always positive. So this is 5 feet. Does it make sense? Is it reasonable? Hypotenuse is always the longest side. Is it here? Yes. Now this is about as difficult as these problems get, and it's really not very hard. They might move the triangle around a little bit. So if this one's x, that side is x, this is 6 feet, and this is 10 feet. Okay, remember, a squared plus b squared equals c squared. What's our a here? Either 6 or x, it doesn't make any difference, but this one has to be c, the hypotenuse, the one that's opposite from the right angle. So our a squared is, say, 6 squared plus x squared equals 10 squared. Okay? So we have 36 plus x squared equals 100. And like I said, this is about as difficult as these get, and it's really not very difficult. So we have a real simple algebra problem here. We want x over here by itself. Subtract 36 from each side. So x squared equals 64. How do we undo the square? Square root. So x equals 8. Does it make sense? Is it reasonable? Yeah, hypotenuse is still the longest side. So we're probably correct. Okay, and last thing we're going to do, or that we did on Monday, is the distance. I think my handwriting's getting worse. Between 2 points on a graph or a coordinate plane. Okay. Now, a coordinate plane looks kind of like this. So if you have a point here and a point here, and say this one is 3, 1, and this one is 1, 4. What are the distances? What is the distance between these 2 points? Now we have a formula, but the formula is nothing more than the Pythagorean theorem. It's just kind of moved around some. And the distance formula, it looks real hard, but it's really very simple. It's x2 minus x1 closed squared plus y2 minus y1 closed squared. Okay, there's our formula. Now, points on a graph are always in the form xy. Always. So if we have, let's see, find the distance between these two. 1, 4 and 3, 1. Does it make any difference which one's which? No. Let me rewrite this. 1, 4 and 3, 1. Now remember, this is the x and this is the y. This is the x, this is the y. This is the first coordinate, but again, it doesn't make any difference. It can be the second coordinate. So we're going to call this one x1 and y1. This is the second coordinate, so we're going to call it x2 and y2. But this can be x1, y1, that can be x2. It doesn't make any difference. So we have x2. So our distance is the square root of, what's our x2? x2 is 3 minus x1, which is 1, closed, squared, excuse me, plus y2 is, what is that, 1? Here's y2 minus y1, which is 4, closed and squared. When you square these things, it doesn't make any difference what number's in here. It's going to end up being positive because you're squaring it. It's going to equal the square root of 3 minus 1 is 2 squared plus 1 minus 4 is negative 3 squared. Now it's just 2 squared with the square root of 4 plus 9, which is the square root of 13. Just leave it like that. If you want to put it in your calculator and figure it out, go right ahead. I'm not going to do it. It's going to be 3.45, something like that. Okay, everybody get the idea here? It's really very simple, but you look at it and think, holy crap, I can't do this. And most of the time I can't. Distance is square root x2 minus x1 closed squared plus y2 minus y1 closed squared. So what if we have the most difficult one of these kind of problems is if you got some godless negative numbers in here. So let's say we have negative 6, 5 and 3, stupid boy, 3, negative 4. Okay? So our distance is square root of x2 is, remember, they're always in the form xy. This is very important, this x and y misery, because we're going to use it over and over again. Okay, x2 is 3 minus a negative 6. So minus a minus 6 closed squared plus y2 is negative 4 minus 5 closed squared. Now, you can think of minus as the opposite of. So what's the opposite of negative 6? I can't hear you. What'd you say? 6. Oh, yeah, I knew that. So 3 plus 6, or minus is a positive. So it's going to be 3 plus 6 plus negative 4 negative 5 is negative 9. Okay, so we have the square root of 9 squared plus 9 squared, or negative 9 squared, doesn't make any difference. So we have the square root of 81 plus 81, which is the square root of 162. Can we factor this into something where 1 is a perfect square? Yes, obviously it's those, right? So it's the square root of 81 times 2. It's not 9 and 9. Remember, we're adding here rather than multiplying. So the square root of 81 is 9 times the square root of 2. This is the only one that's really very difficult, is when you got these godless negative numbers in here. So just pay attention to them. Go slow with it, or I have to anyway. And just go like that. I think that's all. Y'all take care. Bye-bye. Bye, Bonds.